In lesson 1-1, when we left off in your class yesterday, we were talking about this Galileo problem. We had entered the problems on our calculator under list, right?
Already.
And then we had gone in and turned on stat plot, right?
Mm-hmm.
So, in order to go in and turn on stat plot, let me review because you've slept and you haven't used this since then, so you've probably forgotten. But, and for Natalie's sake, right here is my stat plot menu. So I'm going to want to do second and the y equals button. And you'll notice my plot 1 is already on. But remember I showed you yesterday that if you hit enter to go into 1 here, you want to make sure that this is flashing on. So like if you just arrow over, if it's off, then arrow over and hit enter while it's on, and that will turn it on. The type should already be preset. X list and Y list should be L1 and L2 unless you used other lists, right? Unless you had to use a different column, then you can change that. The mark, again, should be preset, and I don't know, some of you got fancy and changed your color, right? I'm guessing, right? Okay, and then we went into graph yesterday. Now, you can just hit the graph button, right? If I just hit the graph button, we talked that we had dots like this. And I asked if we had all of the dots. Do we have all of our points? I see about, what, 4 points on my screen, and there was more like 9 points that should be showing all together. And we went through how to get there, yes? So we can see them all. Like right now, I'm on a 10 by 10 screen. You could zoom out. I don't guarantee zoom out would be your best option here, though. And so remember yesterday I went into window. We go into window. Okay, and some of you already have these settings changed. But if not, now would be the time to get them fixed. Do I need negatives? Do either of my lists have negatives? We're talking about time and distance. I don't need negatives. So I can make my x min 0. My x max. Well, my x's are my elapsed time, aren't they? So with elapsed time, does elapsed time need to be bigger than 10?
Oh, wait, no.
No, not elapsed time. My distance traveled is my y value, and that one we'll have to adjust, right? So I'm going to leave my x min is 0, x max is 10. Y min, do I need negatives? No. What about y max? Do I go bigger than 10? Yeah, my biggest number is 48. So you at least got to make this 48. I'll do a nice round 50. And then just hit graph again. And then you should have a graph that looks something like mine. Yes? Okay. I'm just going to sketch this in the notes. That way, when you look at it, you know something about what we had happen here. But we used a stat plot. And when we did this, we put our time on the horizontal. We put distance here. And we ended up with something that looked like that, right?
Mine has a line on it.
Okay, so if yours has a line on it, go into your y equals screen. And what it means is you have something graphed there. So clear those out. And then go back to graph. And there it is. Yeah. Anytime you still have something on y equals, it's still going to graph. And I talked about that yesterday, so. Okay, any other issues? Are we good? Now, as you guys were walking out the door, I was kind of asking you, okay, we have our graph to look at. What shape is this? Okay. Okay, and we definitely decided it's not linear, is it? As you look at your calculator, it's not linear. We talked about a curve, and we eventually came to parabola. So this is a parabola, okay? Obviously, we're only seeing the positive half of the parabola. And so right there, we've done the graphical model, guys. The graphical model is this, identifying it as a parabola. The other part of this problem, though, asks us to find an algebraic model. Okay, so algebra-wise, what's an equation of a parabola look like? What do you think about when we talk about parabolas and equations?
X squared.
X squared, right? Basic equation is x squared. Now, could there be a number in front of x squared? There could be. Okay, and so we'll refer to that as a. So a equals ax squared. Officially, I could say ax squared plus bx plus c. However, what can you tell about this parabola?
It's not linear.
Well, it's not linear, but it has a point at 0, 0. Is it going to move anywhere left or right or up or down? No. So we can just use the idea of y equals x squared. So our job is to write an equation now. Now, we can use y equals x squared, or we can use variables that fit this problem more, which is what you'll see the book do. I'm not opposed to you guys using x and y. But if we talk about it instead of x and y, what about time? What are you probably going to use for time? T. Distance traveled? Probably going to do d. And so if we think about that as time being my x and distance being my y, I can think about this scenario as d equals at squared. Now, here's the key. I need to know what a is. I need to know that a is my, if I throw out some algebra words from you, stretch or compression. Those are coming up in this chapter. Those words are coming back. Okay? A is my stretch or compression. I need to know what that a value is. Thoughts of how I could find that a value?
Plug in b value in the future.
Okay, plug in an ordered pair. The ordered pair you can't really pick is 0, 0. That doesn't do anything for you, right? But you can pick any of the other ordered pairs. My brain wants to make it nice. So, me personally, I would use the 2, 3. 2 is going to plug in for x, or what in this case I'm calling t. And 3 is going to plug in for d. No, it's y, but that's what I'm calling d. So if I plug those in, 3 equals a times 2 squared. Do some math, right? 2 squared is 4. So then I have 3 equals 4 times a. And if we solve for a, what is a?
3/4.
Yeah, divide by 4. So a is 3/4, or if you prefer, you could call it 0.75, right? 75 hundredths. Okay. So using this form here, and what I just found, write yourself an equation. Instead of d equals at squared, I can say what?
D equals 0.75 t.
Yep. And I had just started writing 3/4 t squared as you said that, but yep. So d equals 3/4 t squared, or d equals 0.75 t squared. Which actually, as I turn and look at my notes, I have the 0.75 t squared. Both are perfectly fine though. So when we talk about modeling, this is one of the things we do. Being able to look at the graphic model is helping us to get the shape of the graph. In this case, we could identify it as a parabola. Okay? Being able to get the algebraic model is, okay, taking that information, writing an equation. We know a parabola is x squared. So then it's using that basic form to try and find our coefficient there. Okay? Now, in case I forget to tell you later. Well, it'll come up later, I guess, when we graph some stuff. But stat plot being on will sometimes hinder your graph. It will sometimes give you an error and tell you you can't graph it. So you will have to go back and forth and turn that stat plot on and off as you need it. And I can show you an easier way to turn those plots on and off also. Okay, so now don't turn it off yet because we're still going to use it. Okay. Questions on this one? Okay, let's look at example 5. We have another table of data values, and it shows the average life expectancy for persons born in the United States in each given year. The data are drawn from census years between 1950 and 2010. Model the trend graphically and use the graphical model to suggest an algebraic model. So similar to what we did last time. So how are we going to model it graphically?
Do the L1, L2 then graph it.
Yeah. Go in and use our stat plot to graph it. So I'll use the years as L1, the life expectancy as L2, and again we're going to use stat plot to look at the graph. Okay?
How do I get rid of these other numbers in here?
Good question. Do you guys remember? The rest of you remember it from yesterday?
Yeah.
Okay, so you go back into stat, go into edit. You can individually delete each item, which is annoying when you have lots. Or if you go up into the heading, do not delete, but do clear enter, and that will clear out the entire column.
Okay.
What I shared yesterday is you can't accidentally delete the column to where it doesn't exist, which is just annoying. So if I do clear enter, I can clear out those top pieces and enter my new pieces. Oh, I should have forgot to show you guys something. Okay, well. Okay, where did I screw up? I'm asking that out loud.
60.
You don't have
It goes to
60 on
60.
the L1.
Oh, it goes to 60? Okay, there we go. I'm asking that out loud because I do that, but my columns weren't equal, right? So I was like, oh, right, I messed up. Okay, I just stopped too soon on that one. Okay. Okay, you got your values on? Okay. Now, to go back to stat plot, we can just hit graph.
You have to choose them.
Yeah, that doesn't really show me what I need to show, does it? Now, what I don't understand is it should be showing, oh, my biggest one, my first one starts at 0, 10, doesn't it?
Mm-hmm.
Okay, so technically there's a point right there, I just can't see it. Okay. Or no, wait.
0, 68.
That's right.
Here we go.
068, which is off the screen. Okay, so you can try some zooms, or honestly, I would just change the window by hand on this one. Still, do I need negatives? No. So I'm going to start with my x min at 0. How big does my x have to go at least?
60.
At least 60. If you want to put a little bit above 60, you can. Y min, do I need anything negative? No, so I'll leave it at 0. Y max, how big do I have to go? Yeah, 78.7 minimum, right? So I'll go for 80. And now let's graph it.
I went in and put the Y min as 65.
Okay. And that's the thing. Did you do that after you looked at this? Or did you just do that from the beginning?
I did it after I looked at it.
And that's the thing. I was looking at this, I'm like, oh, everything's way up high, isn't it? Could I adjust where that vertical axis starts? You can. The fact that my first value is 68.2, you don't have to have a 0 there, and we can still get the shape of this, which is what we're looking for. And so if you want to do something like 60 or 65 as your starting value, I don't remember what I've used in the past. I'll go 60, and then I'm going 60 to 80. That gives me a little bit clearer picture. Okay. So again, we're using stat plot. What shape do you think you're seeing there?
It's not linear, so like, is it?
So my last one was exactly a parabola, wasn't it?
Yeah.
And in fact, what I said, oh, I forgot to show you guys something. What I meant to do is before we got rid of those values in that stat plot, have you graph that 0.75x squared, because then that would have gone straight through. Okay, and that's, that's kind of the nice part there. But I forgot about that. Although, let me pick, let's see. Here, let me show it on this one real quick. How big did we have to go on that last one? 50, right? So, okay. So those are the points from the last one, yes?
Mm-hmm.
If I go into my y equals and I put in 0.75 x squared, if you watch, it connects them exactly. Okay, that's kind of my proof that it is a parabola and I have the right equation. Does that make sense there? Thank you, Colby, for the use of your calculator.
Mm-hmm.
I just thought someone up there has the values entered. I was going to pick one of my fifth hour kids, but. Okay, this one. I'm going to tell you, okay? It's not exactly something. It's just very close to something. And we're going to kind of do a best fit graph here. What is it pretty close to? Katie already mentioned it. It's very close to being a linear, isn't it? It's very close to being a line. It's not exactly. Okay, and that's just going to, these are models. They don't necessarily have to be exact. It depends on the scenario. And so we are going to think about this as a linear model. Okay, so you've got points that look something like that. Okay, and as I said, we are going to think about it being a linear model. With thinking about it being a linear model, what do you guys know about linear?
X squared plus 2.
There we go. We're going to think linear model. We're going to think y equals mx plus b. Okay, like earlier, we didn't think, oh, y equals ax squared. That was our parabola model. Linear, we're going to think y equals mx plus b. That is our form of the line. What do we have to know here?
And you have to subtract the 2 points, and then you have to plug. No. You have to find M, and then you have to find B.
Okay. I'll have to go with that. We're going to have to find M, yes?
Mm-hmm.
We're going to have to find slope. And we know, how do we find slope? Rise over run, or since my values are kind of not nice neat whole numbers, we can do y minus y over x minus x. Pick 2 points. Now, before we do that, okay, and it's hard here on the graph, you just want to make sure if there's some point that's like way outside the line, you want to make sure that you kind of go through the line. Okay, which these are all pretty close. I don't think it's going to really matter. But before we do that, let me tell you, we're not going to have to find B. Think about this. What is B? What is B? It is the
68.2.
y-intercept. Do we have a y-intercept?
Oh, 68.2.
Are we seeing it?
Darn.
Okay, so that was interesting. Your y-intercept, we already have it. We already have our y-intercept right there. Okay, so what I will say is as you try and find your equation, use that as one of your points. Use the ordered pair of 0, 68.2 as one of your points. Now, in terms of what other point to use, trying to visualize line, it technically doesn't matter. All of our lines wouldn't have to match identically. They would just need to be close. I think I'm going to just use the other end of it and use the 60, 78.7. But I really don't think there's really a bad point there. I feel like they would all work out pretty well. So let's find our slope. Officially, y2 minus y1 over x2 minus x1. So on top, what are we doing?
Yeah, minus 60.
Not on top.
78.7.
There we go. 78.7 minus 68.2 because those are my y values over, now I'll take the 60 minus 0 because those are my x values. So subtract. I got the denominator of 60. Numerator of 10.5. Notice my y-intercept is a decimal, isn't it? It converts this to a decimal. 0.175. Okay. So right there, we have an m value, yes? And we already stated a b value of 68.2. Can you write a linear equation? Y equals 0.175x plus 68.2. Now, I'm not going to forget this time. Go to your y equals screen and type it in. See what it looks like in comparison. Then just hit graph again. Don't change any window settings. Ooh, I like it. That's pretty good. Okay. Okay. Now, as we go, the other page of this, lesson is just solving some equations. Most of which you know the skills, and it's reviewing, putting them all back together. So questions on this one? Mm-hmm. Okay. And when it comes to a graphing problem, remind me I'll talk about turning stat plot off. Okay. Are we ready? Thoughts here of how we want to solve? Example A.
Subtract the x squared plus 10x.
Okay. So by subtracting those two terms, I'm making my equation equal to 0. Okay. I do like the first step. Subtracting 10x, subtracting 11x squared. So I'm going to have 6x to the third minus 11x squared minus 10x equals 0. Yes? Now, do we know where to go from there? Okay. Do we have a GCF? Because if we've made this equation to equal to 0, my first plan is going to be to try and factor and see if it works. So always ask yourself about a GCF, especially when you see something like x cubed. Because if we can factor out an x, we can get down to x squared and maybe have some hope. So GCF of x, I'm going to factor it out front. Then I'm left with 6x squared minus 11x minus 10 in my parentheses. And of course, my equation still equals 0. Now what? Product of AC or slip and slide. Okay. Some of you love that, and some of you are like, nope, I don't like it. So, okay. So if I take that x out front, if you're doing product of AC, I don't know which way I want to go. Maybe I'll go both ways. We'll see. If you're going product of AC, what do we need? A product of what? Negative 60 and a sum of negative 11. And actually, you're going to need that same thing. Do I have some of you who want to do slip and slide? I know, Natalie, you liked it. So, okay. I'll work this kind of side by side here. because you're actually going to end up needing the same thing. Okay? Because with slip and slide, we're going to take that 6 and slide it over, yes? So then I'm going to have x squared minus 11x minus 60. So it doesn't matter which method you use, you're still looking for that same product and sum, aren't you? Have you guys come up with the pair? Okay. 15 times 4 is 60. 15 minus 4 is 11. If we're multiplying to be a negative, we need one of them negative. If we're adding to be a negative, it's the 15 that is negative, yes? Okay. So if you are a product of AC, you're splitting your middle term, aren't you? 6x squared minus 15x plus 4x minus 10 equals 0. If you are a product of AC, or if you were slip and slide, it's x what? Minus 15 and x plus 4. Those numbers just go straight in there. Okay? If you're slip and slide, don't forget to put back in. What do we have to put back in now? We have to divide it. We multiplied it over. Now we're dividing it out. So you're dividing the 6 out here. So then you have x minus 15 sixths reduces to divide by 3, and it's 5 halves. And x plus 4 sixths, which is 2/3. If I go ahead and finish with slip and slide officially, so slip and slide, could you just solve right now since we're going to be solving? Officially, you could just solve, yes? If your job is to factor, then you have to take that 2 and 3 back forward, don't you? So it's x, it's 2x minus 5, and it's 3x plus 2. But that's only going to be necessary if you have to, you know, if we're looking for factored form. Okay, how about product of AC, people? Did you make it happen? I carried the x down. And here's a hint. You made it happen if you've gotten this answer, right? We're still going to get the same answer. Okay, I'm going to split it in half. GCF of 6x squared minus 15x is 3x. 6x squared divided by 3x is 2x minus 15x divided by 3x is 5. Plus GCF of 4x minus 10 is a 2. 4x divided by 2 is 2x minus 10 divided by 2 is 5. Am I getting the same thing? I am. Don't forget, I don't care which method you're using. Did you remember to carry that x down out front every step of the way? Because that's important, right? You just lost a point if you drop that x off because you've lost an answer. Okay, so GCFs of 3x plus 2, matching parentheses of 2x minus 5. Okay, so whichever method you're at, you're ready to finish it off, yes? That x out front, what do we do? Yeah, x equals 0, 3x plus 2 equals 0, or 2x minus 5 equals 0. So we have solutions of 0, 5 halves, and negative 2/3. Okay? And that's why I said if you're just solving on slip and slide right here, you could have just taken your answers and not finished the factoring. Okay. That wasn't too confusing going back and forth, was it? I guess it gave you guys options to work ahead. Okay. So that was a more difficult quadratic equation is what that was. Ready to talk about B?
Mm-hmm.
Thoughts on B? Okay. What is our goal by subtracting this 3 over? I like the step.
Get the square root by itself.
Okay. When you see any type of radical, in this case it's a square root, but any type of radical, we want to get it by itself. So to subtract the 3, now I'm going to have square root of x plus 1 is equal to 2x minus 3. What's my plan once I get my radical by itself?
Square both sides.
Okay, if it's a square root, you're raising it to the power of 2. If it's a cube root, you're raising it to the power of 3. So on and so forth. So we're going to square. On the left, what happens when you square the square root?
X plus 1.
You get whatever's under the radical, right? X plus 1. On the right, what happens when I square the quantity 2x minus 3?
You have to FOIL.
Okay, we're multiplying by itself. We're FOILing it. So realizing it's not going to be just 4x squared plus 9, right? And if it helps for the visual, it's going to be 2x minus 3 times 2x minus 3. So 2x times 2x is 4x squared. 2x times minus 3 is minus 6x. Another 2x times minus 3 is another minus 6x, which is minus 12x, and plus 9. And? Okay, work to make this equation equal to 0, yes? So I'm going to subtract x, subtract 1, because I like my positive x squared here. So I'm going to have 0 equals 4x squared minus 13x plus 8. Okay. Now what? Okay. And whether you're product of AC or slip and slide, I'm thinking about this in the moment. Either way, I would start making your product and sum first. Okay, so like before I slide my 4 over, I'm still going to be doing 4 times 8, so I'm still going to need a product of positive 32?
Positive 32? What?
I have a positive 4 and a positive 8 on mine.
Positive 32, negative 13.
And a sum of negative 13.
Should I do?
I don't know. Do you have a negative 8 here?
Yeah, I don't know why.
Okay. I'm like, tell me why.
I think when I saw subtract 1, I thought negative.
Okay. Well, disagree. Disagree there. Okay, 32. What'd you guys come up with? No one's telling me an answer.
You got it here.
Okay. So here's what I do when I'm stuck. I go through my 32. 1 and 32. Can 1 and 32 do it? No. 2. 2 and 2 and 16. Can that work? No. 3. Does 3 go into 32? No. 4. Does 4 go in?
Yes.
4 times 8. Can that give me 13? No. 5?
No.
Doesn't go. 6?
No.
Doesn't go. 7?
No.
Doesn't go. 8? 8 and 4. Didn't we already talk about that pair?
Yeah.
So now you've hit the middle. We're just going to go back and have all the reverse pairs. So what is this saying?
Doesn't work.
This doesn't factor. So that also means this doesn't slip and slide. Because you would have been doing the same thing, right? So that's why I would say, don't move that 4 over yet because it doesn't work. So I need another plan.
Quadratic equation. Or
No, so just don't do it.
here. Not do it.
Okay. A plan that actually finishes the problem is quadratic formula.
You slap no solution on it.
And then you get it wrong.
But you get half credit.
You might get partial credit for at least getting this set up, but yeah. No, we need a plan that actually gets us to the final answer, which is not just stopping here or anything like that. So quadratic formula is what I would go with. X equals negative b plus or minus the square root b squared minus 4 times a times c all over 2a.
What are they watching over there?
I don't know, but Mrs. Huntley definitely turns the music up louder than Miss Minnick, or the TV up louder than Miss Minnick does. Okay, I used A as 4, B as negative 13, and C as 8. I didn't tell you those numbers as I filled them in. I figured you would figure that out.
Indeed.
Okay. I would definitely clean it up. 13 plus or minus the square root of something over 8. Now, let me clear something up because I saw this mistake on the quiz and I see this mistake every year. Negative 13 squared. No matter what that is going to be a positive, yes? I still had some people on the quiz tell me it's going to be negative, but it's positive. So this is going to be positive, what? 169 minus 4 times 4 times 8.
128.
So we're doing 169 minus 128, which is?
41. That's it.
Yeah. What do you know about square root of 41?
Isn't it happening?
It's not a perfect square.
It's not.
41 is what I would call prime. So I'm not going to find any perfect squares in it because there's no other numbers that divide into 41. So I have circled in my notes that you could leave your answer like this, or
13 over 8 plus or minus 41 over 8.
Yep. You could leave it as 1, or you could split it up. It's not as important that you split it up when we're not working with our imaginary values, but you need to realize it's equivalent. We could also plug this into the calculator and get a couple answers that way, couldn't we? Okay.
Call it a day.
Okay, that problem took longer than I expected because I felt like it was a while ago we started. Maybe I was 2 problems ago. Okay, so I guess we are calling it a day there. At least we have a nice stopping point. So, Monday, I will take a few minutes to finish the next set of the other examples, whether I do them all or part of them, but, and then you will have some work time, question time. If you haven't gotten started, I would try and get started.
Do you know, like, are there questions we can answer?
Anything that says solve graphically, well, some of the solve graphically is easy, but we need a little more insight into that. I don't know off the top of my head where those are, though.
Okay.
Does that make sense?
We'll figure it out.
So, yeah. In other words, it's probably going to end up, I was going to have it due Tuesday by the end of the period, but it could end up very easily being a Wednesday thing at this point. Because we have several problems to
I
do.
love the sound of Wednesday.
I figured you would.
Because